Alright, let's try to find the volume of a solid between two planes. Alright, so we want to find the volume of the solid between the planes. Z equals 2x plus 3y plus 6, and z equals 2x plus 7y plus 8. Right, over a triangular region on the xy plane with vertices 0, 0, 3, 0, and 2, 1. Alright, so let's just set up the integral and for this volume, and evaluating the integral shouldn't be too difficult. Alright, so here. So we have three vertices, 0, 0, and 3, 0, and 2, 1. Alright, so we have this triangular region, so I'm going to just draw a triangle here. Alright, so here is the triangular region we're talking about. Right, then you have two planes. I kind of drew a random planes like that, and the ones that the green one is the bottom one, and the purple one is the top one. So you can see that the solid is going to probably look like this. So it's going to go through here and they go up here. Actually, I'm going to just do a solid. Yeah, this is going to go up here and pierce through here and maybe here. So I'm going to do the solid here. So I'm going to go up here. Actually, there's here and maybe around here. So you would have a solid which looks probably like this, right? And let's see if I can color this. Right, so this is the solid. It's like a triangular cylinder looking solid there. Right, so we want to set up the integral for the volume. Right, first I'm going to try to look at the triangular region on the xy plane. So I'm going to just blow this guy. So blow this guy up. So this guy, I'm going to kind of blow it up here and drew it right here. All right, and so let's see, so you have a 0, 0 is right here, and a 3, 0, so it's a 1, 2, 3, so it's right there. And then you have a 2, 1, so it's a 2 right there and the 1's right there. Right, so we have, right, so we have that, and so this is the triangular region. Right, all right, so let's write the let's see, volume. Right, so we're gonna do triple integral. So we have an integral. Yep, maybe I'll give it a little bit more room. So triple integral here. Alright, so first I'm going to do fix x on y and try to do with respect to z first. And then we can do y or z doesn't. Let's see which one is probably easier. Actually, let's see. This is the region, so I'll probably do it dx first and dy first. If it's not convenient, I will redo it. Alright, so let's do that. Alright, first, so what, let's see, z, so we're going to fix x and y. So let's see, we're going to fix x and y. And so let's say here, it's kind of hard to see. So you can see that it's going from the bottom plane all the way up to the top plane. So for the fixed x value and the y value, So it just goes from bottom plane to top plane. So bottom plane is z equals 2x plus 3y plus 6, and then top plane is z equals 2x plus 7y plus 8. Right? That will cover that. Then we have to cover the entire triangular region. So in order to cover the triangular region, we're going to fix y first. So I have to use a different color. So here's let's say fix y here. And you can see that x value goes from this guy to edge to that edge right there. Right? So we have to come up with the equation there. So here, this line right here, right, has the equation. Right, slope is, let's see, 2 to the right, 1 up, so it's a 1/2 is a slope, y intercept is 0, so it's a 1/2 x, right? And this one right here, the other line, so it's gonna go like this. Alright, so the equation is going to be, let's see, slope is going to be, so this is going to be, let's see, so it's slope is -1, so y equals -1x, and so it's a 3, so that's going to be 3 there, so that's 3 there, so plus 3. Alright, so we have that equation. So in order to find that you're going from here to there, so y is going to go from 1/2 x to y equals -x plus 3. Alright. Alright, then after that, all you have to do is actually, I messed it up, didn't I? So we're going from, so we're doing the, oh, sorry. I have to write it in terms of y, not x. Since y is fixed and this is x, so we have to put x equals. Right, so x is going from, so we have to rewrite this equation as x equals 2y. So we have x equals 2y, right? Then I have to rewrite this guy as, right, so it's going to be x equals -y plus 3. All right, so we have that, so we just have to put -y plus 3, right? So that will cover that. And after that, we start from, let's see, y is going to start from 0, which is this guy, and increase the y value to cover the entire triangular region to 1. So it's going to be, y is going to go from 0 to 1. Right? So this is the triple integral. If you want to do a double integral, we can do the same. It's just the same bound for y equals 0 to 1, x equals 2y, and x equals -y plus 3, right? Then you can just do a top minus the bottom, because that will determine the height. So you have top minus bottom, so 2x minus 2x cancel out. 7y minus 3y is going to give you 4y. And 8 minus 6 is just 2. Right. This will give us the volume of the solid that we're looking at. All right. That's it. Evaluation is very simple, so I'm going to skip that. But this is how we can set up the triple integral for the volume between two planes. All right. That's it. I hope that this was clear.